Okay, welcome to the 9.2 Mass-to-Mass conversion solution worksheet video. This is where I'm going to go through this homework assignment and walk you through some of the problems if any of them gave you any troubles. Actually, before I do this, I'm going to change the settings on my pen to make it thinner. Okay, sorry about that. Okay, here we go. So question 1 was dealing with laughing gas, nitrous oxide, how it's used in anesthetic in dentistry. Here's the chemical equation. And they want to know how many grams of NH4NO3 are required to produce 33 grams of N2O2. Okay, so step 1, start with what you're given. They give me 33.0 grams of N2O2, so that's what I'm going to start with. All right, and then I'm going to divide by the molar mass of N2O to get to moles, because the only way you can convert from one compound to another is to go through the mole ratio, so I need to convert it to moles before I can use the mole ratio. Okay, so I got to figure out the molar mass of N2O, and I should have gave myself some space here, but maybe I'll do it over here. Okay, N. I have 2 at 14.01. O, I have 1 at 15.99. And I add them up together and I get around 44.01 grams per mole for my molar mass or formula unit. So I'm in grams. Grams goes on the bottom. So it's going to be 44.01 grams of N2O to 1 mole of N2O. So if I measure out 44.01 grams of N2O, that means I have a mole of N2O. Okay, so now I'm in moles. I can use the mole ratio where I can convert from N2O to NH4NO3. Okay, so I look at the chemical equation. There's a 1 there. There's a 1 there. So it's going to be a 1-to-1 mole ratio. Now, because I'm in moles of N2O, that means 1 mole of N2O is going to go on the bottom. And that 1 came from this chemical equation here. I'm going to NH4NO3. So 1 mole of NH4NO3. Okay, so my grams will cancel out. My moles of N2O will cancel out. I'm in 1 mole of NH4NO3. And they want to know, hey, how many grams? So I need 1 more conversion. Basically, I'm going to multiply by the molar mass. So 1 mole of NH4NO3. Well, how many grams is that? So I figure out the molar mass of that. Nitrogen, I have 2, 1, 2, each at 14.01. Hydrogen, I have 4, each at 1.01. Oxygen, I have 3, each at 15.99. I add them all up together to get somewhere around 80.03 grams per mole. So that goes on top. So now I've set it up. I just got to punch it in the calculator to get the right answer. So 33 times 1 divided by 44 times 1 divided by 1 times 80 grams of, sorry, I should finish this. And you'll see that these units will cancel out, grams, grams, moles, moles of that, moles, moles of that, and I'm left with grams of NH4NO3. And my answer, and I'm just going to stick it right here because I'm out of space, around 60 grams of NH4NO3. Okay. Second part, how many grams of water are produced in this reaction? So just use what you're given. Hey, they gave me 33 grams of N2O, and now I'm going to go to water. Okay? So start with what you're given. I'll move it down here so I have a little bit more space. 33.0 grams of N2O. I'm in grams of N2O. I got to get to moles of N2O, so I'm going to use the molar mass, and I kind of did that work up here already. So the molar mass of N2O is 44.1 grams. That's equivalent to 1 mole of N2O. I'm in moles of N2O, and I got to get to water, so I'm going to use the mole ratio. So N2O, I'm in moles of it. That's going to go on the bottom. I'm going to put a 1 in front because that 1 is right here on that chemical equation. I'm going to water. 2 moles of H2O on top. All right. So I need one more conversion. I'm in moles of water. I got to get to grams of water. In order to do that, you have to multiply by the molar mass. So what's the molar mass of water? So I'm going to put the molar mass of water up here. I have hydrogen, 2 of them at 1.01. Oxygen, 1 at 15.99. The molar mass of water, all you got to do is add this up, is around 18.01 grams per mole. So 1 mole of H2O is equivalent to 18.01 grams. So now I just punch this all in my calculator. 33 times 1 divided by 44.01 times 2 divided by 1 times 18.01 divided by 1 gives me around 27 grams of H2O that can be made. Okay, second problem. Sodium peroxide reacts vigorously with water in the following unbalanced equation. Of course, you would have to do that, Mrs. Erickson. Give us an unbalanced equation. I'm really not liking the red. Oh, shoots. Okay, here we go. So, first thing you should do is balance your chemical equation. And I didn't do that on the last one, but it was balanced, okay? So I have to balance this. Of course, I didn't give myself enough space for this, of course. But anyways, let's take some inventory. Whoa. Well, I thought I had a pen. All right, let's take some inventory. So I have Na. How many NAs do I have? 2. I have O. 2 plus 1 is 3. And I have H at 2. Let's go over here. Na is 1. O is 1, 2, 3. But my H is just 1. All right, let's see. The H's are not happy, so let's just stick a 2 here and see what happens. 2 times 2 is 4. 2 times 1 is 2 plus 2 is 4. Come over here. I'm going to stick a 4 here, mess everything up. Okay, and then 4 times 1 is 4 plus 2 is 6. So I'm going to come back over here. I already have 2, and I need 4 sodium, so I might as well just stick a 2 there. 2 times 2 is 4. 2 times 2 is 4 plus 2 is 6. Okay, we're finally balanced. Ooh. Okay, what mass of oxygen is produced when 50 grams of Na2O2 reacts with water? So we want to figure out how much oxygen is made if we are given 50 grams of Na2O2. Okay, so I start with what I'm given. 50 grams Na2O2. I'm in grams of Na2O2. I have to get the moles of Na2O2 because the only way to go from one compound to the other, mole ratio. So I got to figure out the molar mass of Na2O2. So I'm going to do that up here. Na, I have 2 of them, each at 22.99. Oxygen, 2 of them at 15.99. And then I'm going to add these up, and I get somewhere around 77 point, 6 grams per mole. So I'm in grams. Grams goes on the bottom. That's 77.96 grams of Na2O2 to 1 mole of Na2O2. Second conversion is the mole ratio. I'm going from Na2O2 to oxygen to figure out the mole ratio. Look at the chemical equation. So I'm in moles of Na2O2. That's going to go on the bottom. So I'm going to put a 2 here because I put a 2 up here. 2 moles of Na2O2 going to oxygen. There's a 1 there. 1 mole of O2. I'm almost done. If I wanted moles of oxygen, I would be done, but they want mass, so it's grams. What's the molar mass of O2? So oxygen, I'll put it down here, 2 of them at 15.99. You get 31.98 grams per mole. So 1 mole of oxygen gas is 31.98 grams of oxygen. The units will cancel out. Make sure the units always cancel out, then you know you set it up right. 50 times 1 divided by 77.96 times 1 divided by 2 times 31.98 divided by 1 gives you 10.26 grams of oxygen gas. Second part, what mass in grams of water is needed to react completely with Na2O2? So we are given 50 grams of Na2O2. That was our given. So you're just going to use that. And they want to know how much water you're going to need. So I kind of already did the legwork up here. Got to convert grams of Na2O2 to moles by dividing it by the molar mass. Now I'm in moles of Na2O2. I can convert it to water. So I have a 2 here. That means the 2 go here. 2 moles of Na2O2. I'm going to water. Here's water. 2 moles of H2O. Again, if they wanted moles, I would have been done, but they want mass. Okay, so I got to multiply the moles of water by its molar mass. What's the molar mass of water? Well, hydrogen, got 2 of them at 1.01. Oxygen, I got 1 of them at 15.99. 18.01 grams per mole. So 1 mole of H2O, I need the moles to cancel out, so it's going to be 1 mole down here of H2O times the molar mass on top. Notice my units will cancel out. Grams of Na2O2, grams Na2O2. Moles of Na2O2, moles of Na2O2. Moles of H2O, moles of H2O. And I'll be left with grams of H2O. So I multiply across, and I get, I'm just going to stick it down here because of space, 11.55 grams of H2O. Final problem. Copper metal is added to silver nitrate in solution. Silver metal and copper 2 nitrate are produced. What mass of silver is produced from 100 grams of copper? Now, I was really mean on this one because I did not give you a chemical equation. So you had to figure it out, right? So let's look at this word equation, okay, and then break it down into a chemical equation. Copper metal, okay, that's just Cu, is added to silver nitrate. We know silver is Ag nitrate. That's a polyatomic ion. Okay, so you have to look that one up. AgNO3. So copper plus AgNO3. So we add these two together. It says silver metal and copper 2 nitrate are produced. So it produces silver metal, which is just Ag, plus copper 2 nitrate. So that means this copper has a +2 charge. Nitrate is polyatomic, it's -1. So that means I need 2 of them, right? So it's going to be Cu parentheses NO3 parentheses 2. Now I need to make sure this is balanced before I do anything. So copper 1, Ag 1, NO3 1. Over here, copper 1, Ag 1, NO3. I got 2 of them. So I put a 2 here, and I put a 2 here. Now I'm balanced. Okay, so I'm just going to draw a line, separate that. So, what mass of silver, this is our X, what we're solving for, is produced by 100 grams of copper. This is our given. So you start with what you're given, 100 grams. And I put that dot there because I was like, when I initially was going to teach this, we would have done sig figs, but don't worry about sig figs, just hit the ballpark, right? And so I got 100 grams of Cu. And I need to get from grams of Cu to grams of silver. The only way you can do that is to use the mole ratio. So I got to convert grams of Cu, which is copper, to moles of Cu. And how do you do that? Well, you divide by the molar mass. So grams of copper, what's the molar mass of copper? Look at the periodic table. The big one in my room says 63.54. 63.54 grams of copper is equivalent to 1 mole of Cu. Now I'm going to set up my mole ratio. Okay, so the mole ratio I get from my chemical formula. Here I look at copper. It's going to be 1 mole copper, because that's what I'm in. So those on the bottom that cancel out. And I'm trying to get to silver. So here's silver. 2 moles of silver. All right, I'm in moles of silver. I need to get to grams of silver by multiplying by the molar mass. So I'm in I'm in moles of silver, so I know 1 mole of Ag is going to go on the bottom. And what's the molar mass of silver? You look at the periodic table. So Ag, number 47, its molar mass is 107.9. Whoops, 9 grams. It's a 9. Okay. So 100 divided by 63.54 times 2 times 107.9, I get around 339.6 grams of Hg, silver. Okay. All right. I hope this video was helpful for those that watched. Yeah, this is going from mass to mass. It's a lot of conversion. It's a lot of work, but it's actually kind of cool that you can do this without actually doing the experiment. All right. Have a good one.